So this question says that there are three sinusoidal waves on identical strings with the same tension. Mathematical forms of the waves are three different values, or three different y equals some sine function, where x is in meters and time is in seconds. Match each mathematical form to the appropriate graph. Okay, well, I'm going to look at these graphs, and I'm going to notice a couple things about them first. First thing is they all start at 0. That's a good thing because we have three sine functions, and if you've noticed, there's no phase shift to it. There's no plus phi term in here, so they all better start at 0. That's good. They also all have the same amplitude, the amplitude of ym. So I know that this point in all three of those is ym, this point is negative ym, peak to peak. All right, what I do notice is different is, well, one other thing that's the same, and it's actually really important, is that all three of these values in here, these are x, y graphs. So this is in meters along here. It's not a time graph, it's a meter graph. So when I look at this, it doesn't matter what my times are for it, it just matters how far along are we. So we're looking at some time. I'm going to say time equals 0. This would make sense because if I put 0 in here at 0 position, I get my 0 point. So I'm going to say these graphs are probably for time equals 0 or some multiple of the period later. But it doesn't tell me anything about this 6, this 8, or the 12. I can't use that information in here. However, the position graph is going to tell us something about how these graphs change. So what I need to do is I need to figure out which one has some value. I know that this value, this in y1, that my k1 is equal to 3 inverse meters. K2 is equal to 4 inverse meters, and K3 is equal to 6 inverse meters. K is not a very useful number to use. So what I'm going to look at is I'm going to look at the wavelengths for each of these three cases. I know I can use the wavelength, or the wave number, our k value, is really equal to 2 pi, or 2 pi divided by our k is going to give us our wavelength. So this is 2 pi over 3 meters. This one is 2 pi over 4 meters. And this one is 2 pi over 6 meters. And I like wavelengths because I can see wavelengths. Wavelength for this one is here to here. This is one wavelength. For this guy, this is the second wavelength. And in the third case, this is our third wavelength. And these wavelengths, I probably should have subscripted them something different because I don't know which ones match. And I think I got them reversed because this wavelength right here, this is a very short. This one is a short wavelength, and this one is a long wavelength. 2 pi divided by 3 is a larger number than 2 pi divided by 6. So I'm looking for, this one has the shortest wavelength, this one has the longest wavelength, and this one has the medium, just based off of the pictures and the number of wiggles that I get in each one. Oh, and a wavelength, just to remind you, is where I start at some location and repeat myself. It's when I get back to the same repeating thing. So I go up, down, back up, then I would start again and go up, down, back up. So this original point on these are all the wavelength. So in the end, my wavelength, this is my longest wavelength. I is my longest wavelength. So wavelength 1 goes with I, wavelength 2, the middle one goes with lambda 2, goes with double I, and our shortest wavelength, lambda 3, goes with I. So I'm looking for y1 I, y2 double I, and y3 triple I. So I have choice A being my correct answer. But to kind of review, I went over, I looked and said this is 3 meters. Or 3 inverse meters. I looked and saw that this coefficient in front of the x variable in each of these cases tells me my wave number. My wave number I can use to compute my wavelength, and I can look at my graphs and see which ones have longer wavelength or shorter wavelength.